The apocalypse has left the world in ruins. It is up to us to innovate and design rescue vehicles and do our part in the battle for humanity. Our solution, the OH-600. The OH-600 was designed to rescue survivors like him, from the walking dead like them, by engineers like these. The aircraft is built around three main requirements. The aircraft is able to land within 2 football fields of empty space in order to conduct inaccessible rescue missions. The aircraft is able to carry 4 tons of supplies to conduct supply drops, and the aircraft is able to carry 30 passengers in order to conduct large-scale rescue missions. There are 2 primary risks to the aircraft: zombie attacks and extreme weather. Zombie attacks can lead to the loss of life and damage to the aircraft, and can be repelled by small armaments. Extreme weather, however, can lead to loss of control and the entire perishment of the aircraft. Inspiration for the OH-600 came from the V-22 and the Dornier DO-31 VTOL transports. The V-22 has overall great flight performance when compared to other rotary-winged aircraft and can carry up to 30 passengers. However, its tilt rotors cause large aerodynamic drag, which is undesirable. On the other hand, the DO-31 is favorable due to its large hull size and increased lift-to-drag ratios. However, the DO-31 design has 2 sets of engines, one for vertical takeoff and one for cruise. This means that whilst the aircraft is cruising, it's carrying a pair of engines that it doesn't use, and thus is carrying dead weight. The OH-600 is a combination of the 2 aircraft. We decided to use the body similar to the DO-31, powered by 2 turbofans. For the VTOL capabilities, we chose to place a set of ducted fans on the wings to provide vertical thrust. We plan on powering the fans with the 2 turbofans. The aircraft has 2 modes, VTOL and cruise. Each one has separate control surfaces and powertrains. The VTOL mode is distinguished from cruise by being powered by only the ducted fans. Pitch and yaw are possible by vectoring thrust from the turbofans in the rear through vertical and horizontal exhausts. Roll is possible through a thrust differential. In cruise mode, the aircraft flies like a regular, fixed-wing aircraft. For the wings, we chose an airfoil design with high laminar flow for better cruise characteristics. As for the empty weight of the aircraft, we took the data from the DO-31 and used 80% of its empty mass as the approximation for the empty mass of the OH-600. This is due to composite materials and technological advances since the DO-31. Overall, the OH-600 has an empty weight of 15 metric tons and can carry 4 tons of payload, including 30 passengers. It can remain airborne for 3.5 hours and travel 2,700 kilometers. The calculations that our engineers performed are on screen. I recommend pausing the video in order to have a closer look. On screen is the model of the final design. And to conclude, the greatest lesson that's been learned during the project was that transparent communication is crucial to the advancement of the project. Every team member, every engineer has to be on the same page. Or else, quite frankly, you don't really get anywhere. TeamA01, signing off.